So, yeah, what we'll get through tonight. It's concrete once again, but concrete in a more commercial perspective. So there's a whole series of resources on here. This Bianco precast is a really good resource as well. Bit of information about steelwork as well. But what we'll go. So have a look through all of those at your leisure. Oh, we'll have a quick look at Bianco precast a bit later as well. But yeah, so very important material in residential architecture in terms of slabs, footings, etc. But also, amazing material for commercial construction, both residential and multi-story residential and larger scale commercial projects. Yeah, very strong, durable material, has high resistance to fire, can stand the test of time, can be cast into almost any shape. Still after you have a building fire, typically the slab remains, but you've got to have that tested once again to see if it's been compromised or not, because at above 1200 degrees Celsius, concrete starts to break down, and so on. But yeah, amazing freedom of design in concrete, cast into almost any shape. It's basically limited cost of the formwork. And I think we've spoken previously about skate parks and things like that as well. And so you've got all your concrete that you can do with various different formworks, but then there's various other shot-fired concrete where you can shoot it onto formwork and trail it off into various different shapes and things as well. So a great deal of flexibility. A lot of that flexibility in what you can do with it actually relies on the plastic properties of the concrete. There are various different mixes of concrete. Some of your off-form concrete that you apply a particular pattern to from the formwork, that has to have a very high slump, so very soft, so a slump that's measured in. You've got your concrete testing cone. Fill that with concrete. Then lift the cone up and measure how much that concrete has slumped. Hey Jane, how you doing?
Thanks. Sorry, I'm late.
That's okay, no worries. Yeah. So we've only just got started. So we're going through concrete tonight, but concrete in a commercial sense.
Yep.
So yeah. So yeah, just talking about some of the applications of it, and as I was saying, in regards to the slump of the concrete, that will determine how well it takes up forms, etc. And yeah, it was some months ago now. I don't know if they'll be doing it into the future, but there was an architectural tour of the city of Adelaide going through looking at various different modernist buildings in Adelaide and modernist and brutalist buildings in Adelaide, and there's a huge, how to say it, concrete plays a very big role in that movement in architecture. So used for primary structures such as load-bearing walls, footings, floor slab, floor beams, and columns. Also used significantly in building a tilt-up panels. Those, they're two types of panels. One are tilt-up panels, one are precast panels. The difference between those are the tilt-up panels are produced on site. The precast panels are produced in a factory. So what we have in this picture is, I'd say these are precast panels. They're done to a sort of detail that you wouldn't expect people to be able to achieve on a site, and then typically they have to be craned in. You're not going to get them lifted in by people, so they're craned in onto their supports, and then they're strutted with temporary supports until other walls go in to lock them together. This may be on a series of strip footings. So strip footings used in commercial architecture as well as residential architecture for various different aspects. However, predominantly we deal with large floor slabs. Also, another feature of concrete is casting that concrete into beams, and a pier and beam system is a very common system within commercial architecture, and certainly in undercroft car parking areas, etc. Those systems are quite noticeable. So once again, concrete and steel. Concrete's great at resisting compressive forces, but not good with tension. So without reinforcement, it'll crack. However, you can use higher strength concrete and also increase its strength by vibrating that concrete as well. So when concrete is placed, you use a vibrating machine that vibrates that concrete, gets all the air bubbles out of it, and you can also increase your strength with that. However, the strength of concrete is vastly increased by adding steel in a tensile sense. Yeah, so like all buildings, reinforced concrete structures need to resist dead loads, live loads, and wind loads. So a bit of revision. Actually, can I get some examples of dead loads, live loads, from either of you? Christian, you.
Dead load. The weight of the bath on the ceiling.
The weight of a what?
Bath.
Oh yeah. Oh, actually, bath. That's a really interesting one. So typically the definition of a dead load is something that was built into the building and the building was designed to take that load. Okay, yes, a bath could be both. So in that sense, bath could be dead load. So we've designed the building, we go, okay, we're going to have this bath in this location, we put the plumbing in, etc. Bath is built in. However, it can also be a live load, and that load also depends upon occupant behaviour as well. Some people the building could be designed for a bath, but then it would never get filled up. So yeah, no, very interesting one. But more dead loads, more things to do with the building fabric. So roofs, walls, things like that. They're all dead loads that apply onto the building.
Is dead load already been made, isn't it?
Yes, yeah.
Live load is pour concrete into the.
No. So live load. So for example, what we can see around here. Okay, so on this floor slab here, we've got the floor slab above and the columns producing a dead load onto our structure here. This is what the structure was designed. When they were designing it, they said, okay, we've got all these loads above, they're transferring onto there. But the designers of this building would have also said, well, at some point in time, they're going to have 50 students in this room, and that's a live load. So the students are in here at one point in time, and then not in here at other times. But the building has to be designed to take those loads as well. So a live load is any load that can be variable, and any load that can be imposed on the building afterwards.
What about benches and kitchens?
Yeah. So a built-in kitchen, you'd consider that to be a dead load. However, things like tables, furniture, live loads. Yeah, because tables, furniture, that can be changed. People do other things with that. And then wind loads. So we've got two main loads happening from wind loads. One is racking forces and one is uplift. There are also torsional forces being placed on particularly skyscrapers, buildings within city areas, because you've got wind channeled by various other buildings about the place, and you may have high wind on one side of the building and shielding on the other side of the building. But in a for your standard residential sense, it's uplift and racking forces. Racking forces is the wind pushing on the side of the building, wanting to elongate that building, push it over, and uplift is the wind pouring over it, that building acting like an aeroplane wing, wanting to suck up.
Did you see in Hong Kong when the typhoon went through, the buildings were swaying?
No.
It was pretty impressive.
Yeah.
I wouldn't want to be one.
So the buildings have been designed for, but they're concrete buildings, are they? Yeah. And that's basically the steel in that, which is well, so with a building swaying, find a decent pen. Okay, we've got our building in Hong Kong doing that. This bit, that's all in tension. This bit's all actually, well, they should go this way. They're pulling apart. This way, in tension. Oh, sorry, in compression. So it's the concrete which is resisting the forces on this side, and it's the steel that's resisting the forces on that side. If we didn't have steel in this structure, it'd be doing that. But yes, resisting typhoons, cyclones, etc., and earthquakes. It's something that we don't really have to do in South Australia. But it was, when I did this course, I studied with a guy from South America who's an architect there in South America, and he was saying that what they do there, designing for earthquakes, is that they use structures more where they have columns and then have infill in between the columns, and they're designed with some flexibility in that, so the structure can actually move around, and a lot of that flexibility is taken up in these joints here, to rather than resist the earthquake and try to be monolithic. It's about designing buildings that do this a bit with the earthquake. So the wind forces happening in a city also impose a torsion, a twisting of the structure. So here in Adelaide, we've got a company called Bianco Precast. So they actually, fairly large company. They actually send stuff out of Adelaide as well, send stuff to Melbourne, etc. And they've got a very big casting facility there. That's all about, manufacturing precast products, either that being cladding panels, entire wall systems, floor systems, or various different building components as well. That casting in the factory allows a lot of control, and so control in terms of just the right environment, so you're not going to get any rain on the panels that you're casting, and it's going to be, because they've got a very good working platform, it's very easy to get all the steel in place and things to be manufactured very accurately. It's been a while since I've been there. I don't know.
Port Road, isn't it?
What's that?
Port Road, Kilkenny.
When I went there, it was on. What's it called? I think it's in Cavan. It's on. Can't think of the name of the road. It's Grand Junction Road.
Oh yeah.
So Grand Junction Road that runs from Jets Cross through to Port Adelaide. It's on that road there. Yeah, possibly they've got several sites, manufacturing facilities now. But that's very very big site, and they've got this yellow thing here. So that's a massive big gantry crane for lifting up all the concrete panels and moving them around. But when I was there, they were saying just your standard sort of slab that you can precast wall panel that you can get onto a truck is about $15,000 worth, but that was, I guess that's getting on 10 years ago now, so that'd be yeah, a fair bit more expensive than that. So with that expense, it's incredibly important to get things correct. Well, it's always important to get things correct anyhow, but yeah, but for, you know, if you're casting any fittings into the wrong place or so, to recast a panel is a very expensive process. You've also got a lot of concrete which is cast on site. So with the Adelaide redevelopment, Adelaide Oval redevelopment, there was a lot of concrete cast on site. With that casting in site, you have less recycling of formwork. Certainly, when, you know, how do I say it? Concrete contractors will keep reusing formwork because it's very expensive, or
Yep.
like form ply.
Even outside the form.
Yes, yeah.
Form boards,
Yeah, all the form boards.
Yep.
Yeah, and so what we can see on this wall here, there's certain imperfections and bits and pieces. So I can see these little dots here. They're from previous nail holes. So that's from when this form board got used at another spot, and things were nailed to it. And so they keep reusing these form boards.
Yep.
But still, there's only a certain number of times you can keep reusing these things, or if you cut them, of course, you don't want to rejoin them, all that sort of stuff. So formwork can actually be a very expensive part in the whole casting of the concrete. So it can account for up to 40% of that construction cost. Typically, your concrete costs are going to be around, you know, the $280 to $300 a cubic metre of concrete.
Yep.
But then your formwork cost can also can equal that as well. And that's, yeah. So in a residential sense, where you're doing a residential slab, your concrete formwork is really simple. What you have, you start with predominantly you start with a flat site. You dig trenches with an excavator, and then so we've got our flat site, dig trenches, excavator, and then on the outside of your trenches you erect your formwork there like that, and that's pinned back, and then our slab is cast within that formwork. Does that make sense, Jen?
Yeah.
However, with something like, you know, the seating arrangements at the Adelaide Oval, your formwork's going to be far more complex. So you've got curved forms, you've got stepped forms, etc., and they'll be setting up a whole series of form boards like this going up, and then they'll cast sections, etc., within those. And then, do we have any? No, we don't have any fairly crazy pictures. Also, the addition of steel in concrete, it's done in several different ways. Your standard way is to use deformed reinforcing bar, so your standard Rio, and we've got our various different sizes, sort of N12s to or N36 or so bars that delineates the actual size of the bar. Typically N12s, N16s is what's used in residential architecture, but for, you know, sort of out here in this South Road development, yeah, you get, you know, N36s, big thick bits of bar, but also there's reinforcing that happens in concrete where the steel is put into tension as well. The reason that you put steel into tension is that essentially you stretch that steel, the concrete is cast, and then that steel is allowed to settle, putting the concrete in compression. Putting that concrete in compression means that it's going to be more stable initially, but also having stretched that steel a little bit, steel will always stretch a bit, and then it will stop stretching, and then it will snap. So if you stretch that steel just a little bit to the point where it won't stretch or won't stretch much further, then that's using the tensile strength of that steel already. So, so how do I convey that better? So if we've got our concrete beam like this, and we've got some pre-tensioned steel inside there, and that's already stretched, then if we impose a really heavy load on here and want to make this buckle, if we didn't stretch that steel already, it would buckle just a little bit because that steel would have a little bit of give. But if we've stretched it almost to the point that it won't have any more give, then it stays far more rigid. So I'll just quickly grab there's a great video on YouTube that explains this. And I haven't shown you any of this pre and post tensioning before, have I?
I did see something on mega structures one day.
Right.
Well, they're building in Dubai or something.
Okay.
They had all the machines pulling cords and
Yeah.
steel.
Yeah. Okay. Well. Yeah, that one I haven't seen before. So anyhow,
That's the one I think I saw.
that one, the one underneath. All right, we'll have a look at that in a minute. So obviously major civil engineering, but same principles apply. So yeah, so just to put that in context, so typically your bracing capacity of a house will be somewhere between 14 and 25 kilonewtons. So the wind force acting on the side of the house has got to be around that let's say 20 kilonewtons. That one strand is taking 10 times that, and we've got a whole bunch of strands in there. Yeah, actually. So is that loud enough for you as well? Or should? Yeah, that's okay. Yeah, right. Yeah. And I'll just go back, see if, yeah, have a quick look at this one as well. So yeah, so that was pre-tension. So that's where you stretch your strands and then you cast your concrete around it. So that can only be done in a factory setting because you need a really strong restraint of those end plates in your formwork. That's different from post-tensioning. Post-tensioning is something that can happen on site. It's where well, this is 16 minutes. I might go skipping through some bits. We'll have a look. I haven't been through this one myself, but then I'll explain that post-tensioning as we go along. So what you've got in here, you've got your standard reinforcing, and then you've got a whole heap of conduits in this beam, with those very similar strands threaded in those conduits. And those conduits are deformed, so those conduits bind in with the concrete that's cast around them. Okay.
No health and safety there.
No.
Awesome.
No. So yeah. Oh right, yeah, okay, I see what they're doing. So they're creating those circular bits for the stop ends. Yeah, an amazing thing I saw in Vietnam was a scooter getting around with a whole heap of about 6 metre long reinforcing rods on it. It was just, yeah, it's like jousting in the street. Insane. Let's skip ahead just a bit. So here they've cast the beam, and so those conduits are cast into place, and that beam's gone off. So when we say gone off, the concrete is set. Okay, now they've got a hydraulic powered jack there, and then they've got these collets on here, which are one way only, so they can pull the strands out, but then those collets are this sort of shape, well, like that. So the steel strand goes through there, so and they grab that strand like that, so you can pull it out, but they'll stop. And that's the hydraulic jack that just stretches the strands in place. So yeah, so they're just measuring the jack as it comes out. Other ways I've seen this done before is just before you jack them, you spray paint the ends. You jack them, take the jacks away, measure those spray painted ends. Right, yeah, so just adding collets to another section, jacking those as well. I just wonder if we get to see what happens afterwards. No, it doesn't. Yeah, what I was hoping to see is a grout pour at the end as well. See if go through this. See if they've got it. No, so once again, yeah, that's showing only the tensioning component. I'll just quickly have a quick look for post tension. So we've got this one, yeah. So I'll skip through this one fairly quickly because we've seen. Well, actually, show you right at the start. So what they've done is they've made up their steel strands to all the right length. They're knurling the ends of them, so they'll go in only to a certain extent when they pass them through. Then this is where they're actually, I'll make that full screen. Sorry. That little piece there, that's just a piece of formwork to stop concrete going in that section there, so they have a small space for working in with the jacks. So, and these are their conduits. So in this scenario, they've got that much flatter conduit, and that lays through the slab. Then they pour concrete over top of all of that. So that's ready for the pour. Also, this slab they've got, yeah, it's a bit hard to see there. You can see it just before. They've got, yeah, there we go, some tensioning strands going in both ways. It's what's called a two-way slab. And I'll actually, after this, I'll draw up here on the board what the difference between a one-way and a two-way slab is. So that's doing the concrete pour and vibrating all the concrete in. And that's where they just break away their forms there for gaining access to tensioning the strands. And all this we saw before in the other one. So that's marking them for measuring the distance. See if we measure the distance. Yeah, so yeah, I think this one they pour the grout in a little bit. So what they're mixing up is a very very plastic grout, so grout that can be pumped in and flow through those conduits. So that's it there. So they just pump. So our conduits that include our stressed strands, they fill those conduits full of grout. So the steel strands bind to that grout, and then once you've got grout pouring out one end, you know it's completely full. And then that then applies that load to the concrete thoroughly. One major difference between the pre-stressed and post-stressed concrete is that with a pre-stressed, we've stretched our strands already, and then we cast all of our concrete around those strands. Now, it's never a good idea to go coring through reinforcing anyhow, but if I cored through that concrete of a pre-stressed beam, it may not be too detrimental because that strand is fixed to all that is bound really well in the rest of that bridge beam. But if we use a post-tensioned where they're stretched and then grout is pumped in there and then I cored through and I hit one of those strands, because it's not bound with the rest of the concrete beam very well, that whole thing can go and explode and the beam can collapse by breaking one of those strands. So for that reason, it's very important if you're going to be cutting holes through concrete, suspended concrete slabs, to know whether they're pre-stressed or post-tension slabs, because coring through a post-tension slab can cause it to explode in a dramatic fashion. Also mentioned about the one-way and two-way slabs. It's in a one-way slab is where we've got a floor slab that spans between 2 points of support. So we've got our 2 points of support here, and we've got our slab that spans between those. We'll have our reinforcing predominantly on the bottom, sort of 50 mil edge distance from the bottom to resist those loads as it spans between those supports. With And what we don't want to be doing is actually adding any load-bearing walls in there. So looking at it from the top, if we've got a one-way slab with our reinforcing going through here like this, and so our load-bearing walls underneath there like that, if we added a load-bearing wall here and we put pressure on that, we can induce cracking along that in that direction. So a one-way slab should not be supported on the sides, whereas a slab with reinforcing in this direction can be supported on both sides as well. So that's pre-stressed beams, but you can also get pre-stressed floor slabs. One place that do them, well, they're in, I think they're in Perth now, is Delta Core. So they do a pre-stressed floor slab like this. Yeah, it's actually a relatively cost-effective way of getting concrete slabs and doing concrete flooring. So it's also sort of within the price range of your standard residential architecture, well, not your standard residential architecture, but yeah, but within residential architecture. That's whereby they've also got void formers that remove concrete from where it's not really needed. So those slabs obviously have to work in a one-way, or one-way slab, because if we because all of our reinforcing is heading through these sections here in those bits there. So it's pre-stressed, and then they're cast in the factory, and then trucked out to site. Because they're all hollow on the inside, they're much lighter than a standard fully cast piece of concrete. Can you guys think of why they would be hollow? Why we wouldn't fill them full of concrete?
Because of too much stress.
Too
much stress.
Yeah, well, in terms of
foundation.
yeah. So there's the thing is that concrete that's in the middle of the beam isn't really needed. As we in our concrete beam, got our big thick concrete beam like this. We've applied load to this. This section up here is in tension. This section here, this section up here is in compression. This section here is in tension, and the amount to which each section is in compression and tension decreases significantly as we get toward the center here. So this piece of concrete, this bit in the middle, is really not doing anything. It doesn't help us out with the strength. So because it's not really helping us with the strength, if we fill the whole thing full of concrete, we're using extra concrete that's not providing any additional strength, but it's providing a lot of extra weight. So you can actually do away with a lot of that concrete.
At what point would you be using pre-tension concrete? Like how many stories?
Well,
because you wouldn't need it for like a two-story house, would you? Pre-tension concrete.
Well, you may not need it. The thing is, you get fantastic spanning capabilities out of these. Those spanning capabilities mean less internal walls, greater freedom in a lower floor, for example. Or if that's just a suspended ground floor, less support into the ground. So it's always going to be a trade-off of what do those spans enable the design, and are there cost savings elsewhere that offset the pre-tensioned concrete. I looked into it. It was around $100 a square metre to do. So it's not hugely expensive. Yes, that costs more than just forming up a slab on the ground, slab on the ground. What's it going to be? Around the $50–60 a square metre for doing that once you take into consideration your formwork, etc. So about double that cost of a standard cast slab, but you end up having a lighter structure and greater spanning capabilities. So you may use it in a second story residence, and it may be cost effective to do so. But it's the sort of thing that once you start working on a larger project, being able to have all this stuff cast off site, do your major structure for the building, and then just crane these sections in, means your building goes together very quickly, and you're not waiting for concrete to go off. Also, not so much for residential architecture, but pre-stressed T-beams as well. Works on a very similar principle to that delta core that has hollow holes through it. This is just essentially a series of beams like this. If you wanted to be more efficient with that use of concrete, you could form voids through that. But using much the same principles as what a truss design relies upon. So the advantages of pre-stressing concrete floor slabs can be cast in thinner sections, reducing overall height of building. Important in some aspects, sometimes not important. As I mentioned before the class, in regards to things that councils are very concrete on, roof heights, etc., like heights above ground level, that might be important. If we can get away with a 100 thick slab that spans the width of the building, as opposed to a system of floor joists and flooring on top. Floor joists might be 350 millimetres deep. That's an extra 250 millimetres of building we get per floor height. That might just be enough to sneak a 3-story building into an area where other options would only get a 2-story building. Certainly lighter structure, because you're making better use of that concrete. You're putting the concrete in compression, the steel in tension already, so it increases those spanning capabilities for the actual weight of the material, and then you're removing that concrete from the inside as well. It can be good for watertight slabs. So concrete's fantastic in its lack of permeability for water, fast construction, less deflection, and greater crack control. So post-tensioning, steel tendons are stretched after the casting and the curing of the concrete, and prevented from bonding to the concrete by passing them through a sheath that is cast into the concrete. So that's a necessary thing, because we can't just put them into the concrete and then stretch them out. Post-tensioning can be done in a retrofit fashion. So to save buildings that are having structural issues. So one of those is this fairly famous building called Falling Water, where we've got amazing cantilevers out over top of a waterfall. So post-tension cables were threaded through ducts on the south parapet, allowing them to be hydraulically tightened from the exterior. Provides large tensile forces equal to but opposing the compressive force, introducing reverse forces that relieve the stress on the existing girders. So with your concrete in a commercial setting, the formwork, it's a very expensive part of the process and very labour intensive as well. There are several several different ways of doing forms. One is with form ply, which is a very thick, solid plywood that has a very smooth finish on the edge of it. And then those joints, if you're doing very neat joints, the joints are siliconed together, so so you don't get these. So this is a very rough finish. So what they've done with this wall, they've just got form ply, form ply, form ply, and haven't dealt with any of these joints. If you wanted to get a much smoother finish at all of those joints, you run a bead of silicone and then you spray it with water and wipe it off to get that really smooth finish, that smooth transition between your forms. But another way of doing it is with Bondec, for doing slabs. That's a metal. I'll bring up a picture of some Bondec.
So how long would the concrete, if you're doing a floor, need to cure for? A month or so?
No. So depending on whether you've got accelerators or retarders in the concrete. So accelerators are compounds that make the concrete go off really quickly. Retarders for when you use, typically when you're working in summertime. So you want to slow down that process, that curing process, and also depending on the thickness of your slab and the cement water ratios as well, drying times can differ. But typically you'll be if you do a slab really quickly, you'll be troweling it off in about 4.5, 5 hours from when you pour it. Troweling off, that means you can already walk on it, and it's solid enough to walk on, and then you get your trowel on there. Then the next day, it will, you don't want to go dropping any tools on it, but the next day you can actually walk around on it fairly safely, and also it's the next day you start doing things like cutting your control joints into concrete. At that point, I guess essentially you shouldn't be working on the slab in terms of tilting up wall frames and doing these sorts of things. Some people do. The best practice is to leave it for 5 days before you start doing that. But some of these residential projects, they'll be on that slab in 2 days doing that work. You just have to be really careful with fixings near the edge. So if you're dynabolting to the edge of a slab or something like that. Concrete reaches its design strength in 28 days. So, what's that?
That's what I thought.
Yeah. So at that 28-day mark, it's reached its strength as it was designed for. But yeah, you can start. Look, I don't really want to say when you can start stripping form work away and things like that. But you can certainly people do it in less than that 28 days. So here are some images of Bondec. Oh, that's a pretty decent one from underneath. So what it is just basically steel tray that all clips together like this, and that ends up becoming the reinforcing for the concrete, because the concrete binds to that, and then all that steel ends up being on the bottom of the concrete slab. It gets used both in residential and commercial architecture. You shouldn't use it in exposed coastal environments. What's that?
That's what we've got at our house.
Right, Bondec?
Yeah.
Yeah, is it rusting?
A little bit.
A little bit? Yeah. Yeah, I've seen some it's on a place that's down at Carricklinga actually that has a Bondec slab cantilevers outside of the building, just get sea spray on it.
Yeah, it doesn't cantilever though, it's inside.
Oh, it's inside and it's enclosed, yeah, okay. Yeah, well, okay, yeah, it shouldn't be used outside in an exposed marine environment, because it rusts away, and when that Bondec rusts away, that's your reinforcing rusting away, and then you're just relying on the tensile strength of the concrete, which is not very much. But as long as that Bondec stays in place and stays protected, that provides that tensile reinforcing at the base of the slab, and it provides it right at that point where it's used the most as well. So if we look at our slab here, it's this bit here where the tensile force is greatest. You're actually putting your steel where those tensile forces are the greatest. So it's a fantastic invention. And this is the sort of finish you get underneath. Is that what it looks like in your house?
Yeah.
And that's it before we, well, I'm assuming there's no concrete cast on the top of that. So you get your formwork in place. This formwork here, this looks like some form of form ply, and then there's all the acro props underneath that. Much of that structure can, once that concrete has gone off and has reached a determined strength, all that formwork can be, all that support structure can be taken away. Oh, there we go. It's exactly the same image. So provides a platform to work on, less reinforcement required, and minimal propping required, because those depending on your spans, the formwork has to be designed to resist the weight of that concrete without the the interaction between the concrete and the formwork to create that strength. So the bond deck still does need to be propped. You can't span just really long distances and then pour concrete on it. It'll sag and fall through. So there are spans, certain spans that it's capable of for certain thicknesses of slab, and then it has to have that intermediate propping if you exceed those spans. Another way of forming up concrete is slip forming, and this is what's done typically for things like lift shafts and so on. Actually, those concrete columns out there, I think they were cast in one go, but that's also another use of slip forming as well. That will provide you with a continuous, a seamless cast concrete. So that's simply where you've got your formwork that keeps getting lifted up as the concrete gets poured. So you're pouring concrete and you do it in, let's say 1 metre lifts, and then you lift that once that concrete has gone off enough. You lift that formwork and cast more, etc. So that's an image showing that that slip form construction. So concrete is an incredibly good material in compression, but still it compresses just ever so slightly. So high-rise structures will shorten during and after construction. That's due to the elastic nature of concrete and its characteristic of initial shrinkage during the curing process. As concrete goes off, it loses moisture, it loses volume, and it shrinks together and starts pulling in together slightly. I don't know if either of you have ever noticed on just residential slabs where you've got your PVC pipe coming through, concrete actually shrinks away from those PVC pipes just by a few mil, and you can move them around. That's because the concrete is losing water and decreasing in volume as it goes off. So building designers need to cater for this effect, particularly in relation to curtain walls and vertical transportation systems. Because our lifts, as in passenger lifts, they need to meet the floor exactly. But if we're dealing with a high-rise building which is compressed by 30 mil or so over the entire length of that building, by the time we get to the top floor, that lift has to be adjusted. So our heights of that have to be adjusted to cater for that building shrinkage. Also, in terms of curtain walls, if we've got curtain wall glazing, that's glass that's all the way down the front of a building. Typically, that's mounted to stand off the building. If that building shortens slightly in its life. What we don't want is that curtain wall glazing hitting the paving beneath or hitting the concrete slab beneath. So typically what is done is that curtain wall glazing sits in, so a channel is cut into the concrete slab down beneath. That curtain wall glazing sits in there, and then it's like a mastic or something like that to fill that amount. So the glazing can actually push down into that concrete slab ever so slightly. As well as precast concrete being used in a structural sense, it's also used in the cladding sense. So the first one on the left there, it's Festival Theatre, and then next to that City West campus. We've also got non-structural cladding panels used on the Flinders University building across the way here as well. So that's it for the slides of commercial concrete or concrete for multi-residential construction. Having just a quick look at Bianco Precast, so they do a whole bunch of different projects and products. Does anybody know where that building is? Which one that is? It's familiar from how to say architectural images online, but I think it's over in Melbourne.
Yeah, it looks like it.
Yeah, we can see V-line.
What's that?
V-line.
V-line.
Yeah.
Yep.
That's the trains.
Oh yes. Yep.
Trains.
Yeah. So yeah. So train station somewhere in Melbourne. Actually, well, just quickly, yeah, we'll go view all projects. Yeah. Right. So various different colours and forms. So I mentioned off form before. So the concrete is simply poured against the mould surface, which may be flat, ribbed, wood grain, textured, etc. Has everybody seen wood grain textured off form concrete before? I'll grab an image of that. So that is this stuff. Yeah. Now where was I? I was looking at some just the other day. No, can't remember. So you can actually use timber boards to produce this to an extent, but typically this is actually done with a flexible membrane that's put inside the formwork and that has that wood grain texture. It's actually really quite expensive. Oh, that's right. I was looking at it at the Central Market. So in the Central Markets on either side of Moonta Street, there you've got so on the western side you've got the old food court, and the northern side, sorry, on the eastern side you've got the new food court. The old food court's just been done up recently, and they've done a whole bunch of work. They've used this off-form concrete there as the entry to that, and I was standing around waiting for someone. I was just having a look to see if I could see any similar sections through it. But yeah, so yeah, wood grain off form concrete. See that? Yeah, that one looked to my eye. That one looks, yes, okay. So we've got this piece here is exactly the same as that piece there. That one's a fairly obvious one. Right. Where were we? Where's Bianco's gone? But there's all sorts of effects you can get from off-form concrete. The exposed aggregate, that's a fairly interesting one in how that one is produced. So that's produced, I mentioned earlier on about accelerants and retarders in concrete. This one, they spray a retarder onto the formwork, so the concrete can be formed, but that concrete that comes in contact with the retarder on that formwork doesn't go off. So it goes off really slowly. So then they can pull the formwork away and blast away all that loose concrete, the stuff that hasn't gone off, and expose the aggregate. But it has, what does it say in here? Suppose care is needed to match the retarder strength to the aggregate size in the concrete mix, because you've got to get that, just right. If you add too much retarder for the size of your aggregate, then when you blast away the non-set concrete, you'll get aggregate falling off. So that's a sandblasted finish. So we've got our cast, our unsandblasted side here, and then that's the sandblasted finish. Similar, but slightly different to acid etched. So acid etched is, cut away less, but still a textured finish. Is that the extent of it? Is it? No. Yeah. Polished. So a lot of people would know certainly polished concrete, and you can do that with your precast panels as well. It's just a matter of no, that's not the building. There's a building in the city. I can't think of its address. I'll quickly have a look on Google Maps in a minute to find this building, and then see if I can show you. But it's very similar to this, and that was done in, I think, the late 70s, early 80s. This building in Adelaide, whereby they cast the concrete into ribs, and then two guys just with hammers broke all the edges off all those ribs to create this rough texture. So the building in the city is very, very much like that. This one, well, I guess that's been cast, and then that's happened in the factory. And you can also get precast panels with faces of brick cast in as well to make it look like brickwork. While we're on it, I'll quickly find that building in the city. So I reckon that's right. It's not that far from Victoria Square. I'm gonna hazard a shot that it's here. It doesn't want to drop in there. I don't know why. We're not zoomed in enough. No, it's St. Aloysius College, so probably not that one. I reckon it might be this one here. At the top of Victoria Square. It'll put us down at ground level. And then rotate around. Yep, that's the one there. So this building there, all that does everybody, do both of you know that building?
Yeah.
Yeah.
Yep.
It's the education centre.
The education centre.
Yeah. Department of Education or something like that.
Right. All that happened by hand. So yeah. So it was initially cast with all these ribs, and there was a couple guys, brothers, that would just go bang, 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 bang. Yeah. And if we, for a long way, yeah. But there's some interesting concreting stuff around in the city. So back to Bianco's while we other products. This one's really cool. Like that Delta Core, Bianco's do a product called Bubble Deck, where they use recycled plastic balls that are cast. So you cast a floor slab, and then you cast the reinforcing in place, and then you cast those void formers in there as well, in the position that where concrete is not needed, and then those slabs are craned into place on site, and then concrete is poured in the top of them. So I guess the reason they'd crane them into site half completed like that is because they're far lighter. Once you start, if you create them completely, you've got a lot more transport of concrete on site. And I guess you don't, in this scenario, you have the flexibility of adding more reinforcing in various different weight bearing scenarios. So you might see that getting used about the place as well. So it's that similar concept of taking the concrete out of where it's not needed, so reducing weight. So that's a couple of things that Bianco are doing. Now, what else we got? And also have a look at this link as well. So this is the concrete and cement, concrete and aggregates Australia. There's a great deal of information on here, design guides for reinforced concrete design handbook, guide to industrial floors and pavements, and guide to concrete for houses, guide to off-form concrete finishes. So there's a whole lot of guides on there for your various different applications of concrete as well. So I'd suggest that's a great area for your research. So that's the extent of the concrete in the extent of our what we're going to cover this week. So from here, Jane, you missed out at the start of the lesson. I was telling Christian that tonight's the last night for 3 weeks. So we're back here on October the 18th.
18th of October.
Yeah, 18th of October. So yeah, we've got next week, which is just a marking and resulting week, and then 2 weeks holiday.